A sample gathers information from only part of a population. So if you're trying to figure out, for example, who's going to vote for which president, you're not going to ask, it's not really feasible to ask everybody in the country who they're going to vote for. Instead, they take a sample. The sample proportion is the ratio x over n, where x is the number of times an event occurs in the sample size n. So in a random sample, all members of the population are equally likely to be chosen. That's what it means to be random. And bias occurs when part of the population is over or underrepresented in a sample. So there's different kinds of samples. Some are self-selected, convenience, and random sampling. So in a sample of 500 teenagers, 328 had never attended a popular music concert. So you're not gonna ask all the teenagers. You're just gonna maybe take 500 and try to pick 500 teenagers of all different socioeconomic statuses, younger teenagers, older teenagers, males, females. Keep it random. 328 had never attended a popular music concert. Find the sample proportion of those who never attended a popular music concert. So what you'd want to do is just do this 328 divided by 500. That's it. And then you're going to write it as a percent. Okay, second example. Identify any bias and try to give a suggestion how you cannot have that bias. So the Sunnyvale High School Student Council Dance Committee is trying to decide whether to have a band or a DJ for a fall dance. They decided that each of the 4 community members should survey the students in their homeroom classrooms. There's some bias in this because you're just asking 4 committee members that are on the dance committee already to ask people. So really think about maybe our student council population, how they're probably more, like maybe you have more upperclassmen on this dance committee, so you want to get more people. So you should ask outside classes. So not just keep it to those 4 classes. Maybe they could do a small survey in all the classes. B, a committee wants to find how much time students spend reading each week. They ask the students as they enter the library. So they're entering a library. So a library is a place generally that has books, things that you read. So this would be biased because in a library, people are more apt to read. And how you can change it, maybe they should just stand in the front of the school. So just stand in front of the school and ask people how much they read. So you're getting all different walks of people when they walk in. C, the students planning the junior class party want to know what kinds of pizza to buy. They ask the pizza restaurant what kids sell the most. I actually don't have anything wrong with that. I think that's pretty good. So they want to know what kinds of pizza to buy for a kids' party, and they ask the pizza restaurant what kids get the most. So I think that's good. I think that's a pretty good sample. And then D, the county road department wants to know which roads cause the most concern among the residents of the county. They ask the local restaurant to hand out survey forms. So maybe if you're asking a local restaurant, maybe that's just in one spot. So you might want to, if the local restaurant's on the east side of the town, maybe they just only have people that are from the east side of the town answer. So I think you should go to more, a couple different areas, so then people are using different rows. E, a politician wants to know what issues are most important to the voters in his district. He spends all day Tuesday talking to people as they enter the grocery store. Well, that's pretty good, except for maybe not everybody goes to that grocery store. So you might want to get other opinions. So maybe you want to get a grocery store, a library, a bank to get other people. Because in many families, there's only one person in the household that does the shopping. Either the parent one of the parents might do all the shopping. And then F, a politician wants to know the voters' views on an important issue. She has a campaign worker call people randomly from the book. Okay, this might have been good maybe 20 years ago, but now people don't necessarily, they're not in the phone book because they have cell phones. They're just not they're not putting a phone number in the phone book. The size of a sample affects its reliability, how much you can count on it. So if you're trying to figure out what teenagers think, the more teenagers you ask, the better your sample is going to be. The more you can rely on it. So the law of large numbers states that the variation in a data set decreases as the sample size increases. So the greater your sample size, the more people you ask, you're going to have less variation in the answers. So it's going to be more consistent with what the whole population is. So if there's millions of teenagers and you're asking 1,000,000 teenagers versus 100, you're going to get closer to what actually teenagers are thinking. So standard deviation is variation in a data set. So if in a survey, students were asked to rank the importance of their relationship with their parents, the response scale from 1 to 5, with 5 being extremely important, use the information to decide which sample was the greatest in size, likely the greatest. We don't know for sure, but if this has the lowest standard deviation, then that means that this had probably the greatest sample size. So this one. A sample proportion should be reported with an estimate of error called the margin of error, and it's based on the standard deviation. The larger the sample size, the smaller the margin of error. Kind of already talked about that. So you've probably have seen margin of error a lot when there's been elections. So we think that President Obama is going to win 51% with a margin of error of 3%. So that means that if you had 51%, you would add 3 and you would subtract 3 to get what you actually think he's going to win by. So the more people that you ask, the larger your sample size, the less error you're going to have. So the margin of error can be found by doing 1 over the square root of n, where n is the sample size. So an example, an opinion poll about the popularity of a mayor has a margin of error of 5 plus or minus 5%. Estimate the number of people who are surveyed. So what I'm going to do is I'm going to put the number of people we don't know, so that's going to be a variable. So the number of people is n, but I know that it's plus or minus 0.5%. So I'm going to put 0.05 equals 1 over the square root of n. And I'm going to solve for n. So I'm going to multiply both sides by square root of n. Then I'm going to divide by 0.05. Then I'm going to square it to get rid of the square root. So when I do that, I get 400. So about 400 is a sample. So the number of people that polled were 400. That one came out exact. And next example, for each sample, find the sample proportion, the margin of error, and an interval, so that's new, likely to contain the true population proportion. So to find the sample proportion, remember you do 98 out of 323. So I'm going to divide 98 divided by 323, and I get about 30%. So I'm rounding the nearest percent. So the margin of error is going to be 1 over, it's going to be plus or minus 1 over the square root of the number of people that you asked, which was 323. So I'm going to do 1 divided by the square root of 323. And I get about, I'm rounding to the nearest percent. I keep rounding and rounding, I don't like that, but I'm getting about 6%. So the interval of people that likely contains a population proportion is what you're going to do is you're going to take 30 and you're going to add 6 and subtract 6. So their interval is going to be between 24% and 36%. So this is what you would, so for example, if you could actually get all of the fish that contained a certain chemical, if you could actually get all the fish in the lake or whatever it is, then I'd put money on that it's going to be between here and here. So the higher your sample is, the less the less your margin of error is going to be. So that's why it's important to poll more people and get more samples. So I'll do the next one. A survey of 165 visitors, 102 went to the library to have more novels, or want the library to have more novels available. So I'm going to do the sample proportion. So I'm going to do 102 divided by 165. So I do 102 divided by 165, and that's 62%. I round it again. Then I'm going to do the margin of error, which is 1 over the square root of the sample. Actually, I should change this already from the previous one. This is plus or minus. So I'm going to do 1 divided by the square root of 165, and that's going to be plus or minus 8%. So my interval is going to be 62 minus 8, so it's going to go 54% to 62 plus 8, which is 70%. So this is my interval.